Hello and welcome to a digital lecture for Salt Lake Community College. This lecture will cover section 5.3 for Intro to Statistics, considering describing data from two categorical variables. Now that we have the foundation laid for how to describe a situation with two variables, we want to consider how to describe that data numerically and graphically. If you recall back to when categorical variables were discussed in Chapter 3, we will use some of the same methods, just expanded to accommodate for more than one variable. We'd often collect categorical variables and create frequency tables of the observations for said variable, and we do the same here. If we do so for two variables instead of one, this will be called a contingency table, or sometimes a two-way table, which is a table used to summarize data collected to analyze the relationship between two categorical variables. When we sum up the total observations, we will do so for each row, representing total observations for each category of one variable, and also for each column, likewise representing total observations for each category of the other variable. These totals are called row totals and column totals, respectively. Collectively, these are called the marginal totals. Note that if we then sum all row totals or all column totals, we should get the same number, which represents the total number of observations. However, when making a contingency table, it may be more beneficial to represent each cell with their proportions relative to the row or column totals rather than just the counts, in which case we calculate and display what are called row proportions and column proportions. We can also do the same with the row and column totals, which would be called the conditional distribution. Keep in mind that when making a table of how many people like the color blue, instead of saying something like 15 people in my sample like blue, we could instead change that to a proportion, which maybe is 65% or 0.65 people like blue. Proportions add the context of the total size of the sample or whatever the proportion is relative to. Lastly, if we make a graph out of these qualitative variables, we'd most likely create a version of a bar graph, in this case called a segmented bar plot, which takes each category of one variable and represents it with a single bar segmented based on the categories of the other variable. You will see an example of this at the end of the example below. Now that we have the definitions, let us look at the example below. We have here a survey asks questions about one's happiness and health, with results given in the contingency table below. This is an example of a contingency table. Our two variables here, we have a variable representing the columns. We have poor health and good health, so overall our variable there would be level of health. And then we have one variable representing the row. We have not too happy, pretty happy, and very happy. Together, these are the variable for happiness, or these are categories for the variable of happiness. What we're going to do is create marginal distributions. First, a frequency marginal distribution, and then a relative frequency marginal distribution. Here, I'm first going to look at the frequency marginal distributions. These are relatively simple. All we need to do is total the rows and the columns. So if I do the rows first, 43 and 30 add up to 73, 61 and 189 add up to 250, and 22 and 122 add up to 144. If I do the same thing for the row, the columns rather, I have for poor health column, I have 126 individuals, and then for good health column, I have 341 individuals. When I look at these totals for the rows and the totals for the columns, if I add these together, the row totals or the column totals, I should get the value for n, or how many individuals are in my sample. If I do 73 plus 250 plus 144, I get 467. Likewise, if I were instead to add 126 and 341, I would get the same number. Should always be a good idea to check this. When I change this into the relative frequency marginal distribution for happiness, what I'm instead going to do is take all the frequency marginal distributions shown here on the left, and I'm going to divide those by the overall total, 467. For example, for the not too happy row, I'm going to take the total of 73 and divide that by the total of 467. For the pretty happy row, I'm then going to do 250 and divide that as well by 467. And I'm going to do this for each row and column total that I have. When I do this, I then will also find that when I either add up the row totals or if I add up the column totals, they all should add up to approximately 1. I'm going to take a second here and replace all these fractions with their decimal equivalent. I have taken a moment and replaced every single fraction that I had with its decimal equivalent. Now, note that I did say that these should add up to approximately 1. If you actually take the column totals of 0.270 and 0.730, they do add up to exactly 1. However, the row totals are a little bit off. 0.156 plus 0.535 plus 0.308 actually add up to 0.999. This is simply due to rounding error, depending on how many decimal places you select. This is something that should not be too surprising though, and sometimes this happens. So do not be too surprised when you round to 3 or 4 decimal places and you instead get 0.9999 or 1.0001. Depending on how you round, that could occur. However, if you get something a little bit more off from 1, maybe they total up to 1.03, that is something to check. If we continue through with this example, we're going to look at the conditional distributions mentioned earlier. What we're going to do with the conditional distributions is we're going to look at the relative proportion. We're going to look at how many individuals relative to a certain total have a certain level of happiness, assuming that they have a certain level of health. For example, for the first conditional distribution we're going to deal with, we have conditional distribution of happiness given poor health. Pay careful attention to that last statement of given poor health. That means that we are assuming that the only individuals discussed at this point are those that are in poor health. The other 341 individuals in good health are no longer part of this question. So then, when I'm making the conditional distribution, which is itself another relative frequency, I'm going to instead take the cell total of 43 and divide that by the column total of 126. All of the individuals that are considered to be in poor health. I will also do the same for the rest of those rows. For pretty happy, I will also take 61 out of 126, conditional to the total amount of people in poor health, and then same for 22 out of 126. Total, these should add up to 1. You can also do the same thing for the conditional distribution of happiness given good health. Because this one has that statement saying given good health, this means I'm only considering those individuals that are in good health. So the other 126 people that were calculated to be in poor health are no longer part of my working sample. I am only going to consider those people that are not too happy, the 30 individuals out of the 341 individuals in good health. It's really good to pay attention and note that the given condition here, or the condition in the conditional distribution, defines the denominator that you create in your relative frequency. So poor health individuals, I used all individuals in poor health. That was my condition, thus it created my denominator. Same goes for the good health. The rest of these would continue dividing by the total for that column. I will leave these to you if you would like to change these into decimals. However, if we work with the two questions on the right here, what proportion of people in poor health are very happy? Well, note that the way this is phrased, what proportion of people in poor health, that means I'm only counting the people in poor health. How many of them are very happy? So how many of the 126 poor health individuals are very happy? I actually have that on the table here on the left. That's going to be the 22 out of 126, which gives me an answer of 0.175. Same goes for the second question. What proportion of people in good health are very happy? I am then going to only consider those that are in good health, which is the 341 individuals. How many of them are very happy? Well, that's going to be 122 out of 341, which gives me an answer of 0.358. I'd recommend, if you want to think about these more with conditional distributions, try this problem again, but try changing the variables. Try instead to consider what is the proportion of people who are very happy, or what proportion of people that are very happy are in good health. So basically taking this last question and reversing these two variables. You will get a different answer. If you want to represent these in a graph, we would do so as we discussed earlier with a segmented bar plot. To do so, we create one bar for each category of one variable. In this case, we're creating one bar for each category in the health variable. And each of those bars are segmented based on the categories of the happiness variable. We have the diagonal lines here representing those that are very happy. We have the lightly shaded region representing those that are pretty happy, and the white shaded region representing those that are not too happy, based on this legend in the top right. When we look at this graph, it's pretty nice to see the differences between the two categories and how that represents the proportions of the other categories. And therefore, we can make a statement down here for, is happiness associated with health? If you haven't already answered this question yourself, I do recommend pausing before you see my answer. The way that I would look at this is I would look specifically at the very happy and not too happy categories, because just visually the pretty happy section looks to be around the same size, and the proportions we calculated earlier also backs that up. They're both close to 50%. But we do see a lot of differences between those that are very happy at the top of each of these segmented bars and those that are not too happy, the bottom of these bars. We see kind of a seesaw effect. We see that if you're in poor health, we have a lot of individuals that are not too happy, whereas if we're in good health, we have fewer individuals that are not too happy. On the reverse side, if we're in poor health, we have fewer individuals that are very happy than we would be if we were in good health. We see a lot more very happy individuals. So just based on this, it does seem that I see specifically an association. Be careful with that word. Remember that we're not saying that health causes happiness or vice versa. We're just trying to represent an association or a connection between the two. My answer for this one, I would say it does appear that happiness is associated with health, specifically that a higher level of health seems to be associated with having a higher level of happiness. The inverse also appears to follow with this idea that a low level of health seems to be associated with having a lower level of happiness. If you have any further questions, be sure to review the example videos or ask your instructor.